Dear students, welcome back to my YouTube channel. MCB ChemTube is an online chemistry tutorial, and you get my previous videos either from my personal homepage or from my YouTube channel. And we were discussing about the topic chemistry of functional group, and this third lecture I would like to discuss with you the functional group alcohol and its preparation, basic properties like acidity of alcohol. So our learning objectives are to understand the preparation method of alcohol from carbonyl compounds and Grignard reagent, and the type of beverage and wash, absolute alcohol and rectified spirit. And we will learn some basic properties like acidity of alcohol. And alcohol means the hydroxyl group attached to an sp3 hybridized carbon atom. And you can see it here, the hydroxyl is attached to sp3 hybridized carbon atom. And this is the actual structure of alcohol. And this is the similar to water. And the hydroxyl group contains two lone pair. And the bond angle between this HO and OC bond is 108, and this is the bond length. And you can see it here, hydroxyl group attached to an sp3 hybridized carbon atom, that is, it is having tetrahedral shape. And industrially, there are many useful alcohol products like ethanol. It's highly useful nowadays industrially it's using, and wood alcohol, that's methanol, and iso-propanol. This is extensively used nowadays in especially in sanitizers. Next one, classification of alcohol. Alcohol can be classified as primary and secondary and tertiary alcohol. And when hydroxyl group is attached to a primary carbon atom, it is called primary alcohol. For example, ethanol, ethyl alcohol. Primary carbon means the carbon attached to another carbon. And when hydroxyl group attached to a secondary carbon, it is called the secondary alcohol, iso-propanol. Here secondary carbon means carbon attached to two other carbon atoms. You can see it here. And tertiary, similarly, tertiary alcohol, tertiary butanol is an example for that. Next one is nomenclature. IUPAC nomenclature. And what are the rules? First, we have to find the parent chain and then name the longest chain containing hydroxyl group. We should name and select the parent chain. And next one is numbering. We should start at the nearest to the hydroxyl group. So, and also the hydroxyl group should take precedence over double bond or triple bond. We have to give more preference to this hydroxyl group than double or triple bond. So in this case, you have to start numbering from this end, because if you start numbering from this end, hydroxyl will be getting 3, and hydroxyl should get lowest number. And also 1 has a substituent here, the first carbon. And in this particular example, how do you name this compound? And third point, we should name more substituent and give the number. And you have a 1 bromo substituent here and 3,3-dimethyl substituent, and it is 1 bromo 3,3-dimethyl butane 2-ol. Next one, preparation of alcohol from Grignard reagent. And Grignard reagent, this is a Grignard reagent, RMGX, is an organometallic reagent. Organometallic means the metal bond is attached to a carbon, RM bond, that is organometallic compound. The important point in organometallic compound here, alkyl group will be negatively charged because it attached to a more electropositive metal. So it can act as a nucleophile. So this nucleophile can attack the positively charged carbonyl bond. This is positively charged. And this double bond break, and you get an adduct like this, and this on hydrolysis you get primary alcohol. And with formaldehyde, Grignard reagent with formaldehyde, you get primary alcohol. And Grignard reagent with any aldehyde other than formaldehyde, higher aldehyde, you get secondary alcohol. Because what is the difference here? You have R prime here, so it will be getting here, so it becomes secondary now. And if you are using ketone, that is R, you have both R here, and you will be getting tertiary alcohol. So with Grignard with formaldehyde give primary alcohol, with higher aldehyde give secondary, with ketone give tertiary. For example, formaldehyde with Grignard, you can see that this is the primary. You get if it is acetaldehyde, you get a secondary here, and similar. This reaction is similar one, and this is a mechanism, and you get an adduct here, and this is primary. And acetaldehyde, you get an adduct, then it becomes secondary. What is secondary? Because any higher aldehyde, it gives secondary alcohol. And this Grignard, and with tertiary carbonyl, it form an adduct here, and it gives the product tertiary alcohol. Next one, preparation of ethanol from molasses. What is meant by molasses? Molasses is a viscous product resulting from refining sugarcane or sugar beets into sugar. And what are the raw material available for ethanol production? There are three general raw materials which contains sugars. And one source is beet, sugarcane, sweet, and fruits, sweet sorghum and fruits. Second one, hydrolysis of starch also can give sugars. For example, source of starch is corn, wheat, rice, and potatoes. And third one, hydrolysis of cellulose. So source of cellulose is wood used to paper and crop residues. And this cellulose can be converted into sugars. So these are the raw material. And what we have to learn is how to prepare ethanol from molasses. So first, molasses you should dilute it with water until a concentration of 8 to 10% sugar is obtained. And to discourage bacterial growth, this is acidified, acidified with sulfuric acid. And then make it nutritive by adding ammonia. And the dilute solution obtained as above is taken into a big fermentation tank, and some yeast is added. You have to add 5% per volume. Then fermentation take place, enzymatic fermentation by yeast. Yeast contains two types of enzyme, invertase. What is the role of invertase? Invertase convert sucrose into glucose and fructose. You can see it here. This is the molecular formula of sucrose. It converts into glucose is 6H12O6 and fructose. Then enzyme zymase, it converts the glucose or fructose into ethanol and carbon dioxide. So this is the fermentation process. And after the fermentation process, you will not be able to obtain 100% of ethanol. And the fermented liquid may contains almost 9 to 10% of ethanol, and is called wash. And you have to remove water and other impurities by distillation. And after the distillation, you can steam condenses and alcohol vapors escaping near the top are condensed in the condenser, and you can collect it. And such distillate may contain almost 90% of alcohol. Still it contains water. So next we have to learn what are the types of alcohol. Some terminology we are using in chemistry: rectified spirit. First one, Rectified spirits means it is highly concentrated ethanol that has been purified by means of repeated distillation in a process called rectification. And the purity of rectified spirit has a practical limit, 95% alcohol by volume. So remaining 5% will be water. So that is called rectified spirit. The mixture cannot be separated further by ordinary distillation. Next one, absolute alcohol. How do you get absolute alcohol? What is meant by absolute alcohol? 100% of alcohol, pure alcohol, is obtained by a special method called iso-tropic distillation, which is done by adding excess of benzene. You get absolute alcohol. And what is the role of benzene? Benzene can form a mixture of solvent. It is called tertiary mixture and binary mixture in this ratio. It can form a tertiary mixture in this ratio. Water, ethanol, benzene ratio is as shown here. And this tertiary mixture can boil at 64.8 degrees Celsius. So if you are doing distillation at 64.8 degree, you will be able to remove water completely, and all this three mixture you will be able to collect. And when you increase the temperature 68.2, you will also able to collect this binary mixture, ethanol, benzene, and with this ratio. So here you can remove this benzene. Okay, this benzene can be removed. So when distillation starts, you can remove water completely at this temperature, and at this temperature you can remove benzene. And what is remaining? Ethanol. Finally, 100% pure ethanol or absolute alcohol is distilled at ethanol's boiling point. This is ethanol's boiling point, 78.3 degrees Celsius. Next one, what is meant by denatured spirit? Denatured alcohol. It is also called methylated spirit, and ethanol has sometimes will be having additives to make it poisonous or bad tasting or foul smelling or nauseating to discourage recreational consumption. It is sometimes dyed so that it can be identified visually. Pyridine, methanol or both can be added to make alcohol poisonous. So denatured spirits means methylated spirit or some poisonous spirit, and it can result in blindness or death if it contains methanol. And next one, what is meant by proof spirit? Alcohol proof is a terminology which is used in some Western countries. Actually, it is a measure of content of ethanol in alcoholic beverage. The term was originally used in England was equal to proof means this is actually percentage alcohol by volume into some value. In UK they multiply with 1.8 to 1 into alcohol by volume. So 50% 50 into 1.8 to 1. That value will be considered as proof spirit, and they will label it on beverage bottles. UK now uses only alcohol by volume, not proof spirit as a standard instead of proof, alcohol proof. And in the United States, they make it alcohol proof is defined as it is actually twice the percentage of alcohol by volume. And that means, and suppose an alcohol by volume or percentage is 40%, what is proof? Twice that alcohol by volume, that is called 80 proof. So a alcohol bottle contains 80 proof means that contain only 40% of ethanol. And an alcohol bottle containing 100 proof whiskey means it contains only 50% alcohol by volume. That is proof spirit. Next one, what is power alcohol? Power alcohol is a liquid mixture containing 80% petrol and 20% ethanol and small amount of benzene. So it is useful in the field of automobile to generate energy for its operation. And next one, some properties of alcohol. We will learn acidity of alcohol. And alcohols are weakly acidic, and strong base cannot remove proton to form alkoxide ion. And in the presence of strong base, it forms alkoxide ion. And this is an equilibrium. For example, ethanol, in presence of base, it forms ethoxide. And this is the Ka. It's equilibrium constant. The equation for equilibrium constant is tabulated here like this, and pK is minus log Ka. And how about acidity of alcohol? Acidity of alcohol vary according to the structure. For example, methanol, if you vary, the acidity get decreased if you vary from methanol to tertiary alcohol. You can see it here, methanol. If you go from methanol to ethanol, iso-propanol and tertiary butanol, you can see that Ka is decreasing and pKa is increasing. That means it becomes less acidic. When you go from methanol to ethanol to iso-propanol to tertiary butanol, it becomes less acidic. So, what are the factors that govern the acidity of alcohol? And the alkoxide formed here is called normally conjugate base of alcohol. Usually this equilibrium will be shifted towards this direction when the alkoxide, that is conjugate base, is highly stabilized. When it stabilized. Okay, so any factor that stabilizes the conjugate base, that is alkoxide, will increase the acidity. Next one, what are the factors that can stabilize the conjugate base? One factor is actually bulky group in alcohol can inhibit the solvation of conjugate base. Usually the conjugate base can be stabilized by solvation with water or something like some solvents. So solvent can stabilize conjugate base and equilibrium shifted towards the alcohol. But when you have a bulky group, this bulky group can inhibit the solvation. So, but sterically, this methoxide, this is having less steric hindrance. So the alkoxide can be stabilized. The solvent can approach the alkoxide. So it is sterically accessible because it is less hindered and more easily solvated. But this is tertiary butoxide. Okay, it is sterically less accessible. Solvent cannot approach here because of the bulky group, more hindered and less easily solvated. That is the one reason. So solvation can stabilize the conjugate base. Here the conjugate base is in tertiary is less solvated, then less stabilized, then less acidic. Second factor is inductive effect. And alcohol group of hindered alcohol usually donate electron density and make the alkoxide anion this is less stable. So in this case, this is plus I group. Here you have 3 plus I group. So electron density is donating towards this oxy anion. So there will be more concentration of negative charge rather than delocalization. So this plus I effect can be, because of this plus I effect, it can destabilize this conjugate base. Whereas this can be more easily understand. If you are using electron withdrawing group, that is minus I group, this negative charge decrease on this oxygen, then it become more stabilized. So minus I group can delocalize the charge over the whole molecule, then it can stabilize the conjugate base. Whereas plus A group concentrates the charge on oxygen atom, so it can destabilize. Then the conjugate base will be more destabilized. Then it becomes weak acid when compared to ethanol and methanol. So, in summary, we have learned the preparation of alcohol from Grignard reagent and carbonyl compound, and we have learned what is meant by wash and absolute alcohol and rectified spirit, and we studied the acidity of alcohol like ethanol, iso-propanol, and tertiary butanol. Okay, that's all. Thank you for watching.